In this video, I am going to discuss with you regarding the graph. Right? We are here to discuss about the graph of velocity versus time, or displacement versus time, or acceleration versus time. We have to see these graphs. But before I go for the graph, I must tell you something about the simple graph that we come across. See, whenever you come across this kind of thing, any linear equation x and y will be representing a line. We have another equation which equation line can be put in the form of this also. X by a plus y by b is 1, and the graph of this line is basically this. This is your graph. This is a0 and 0. This is x and y. So whenever you come across any linear equation in x and y, you just try to put it in this form. This is also equation line, but this will be more useful for you. You come across any equation in x and y, you just try to put it in this form. For example, if suppose this is the equation and you want to draw the graph of this, then this can be put as x upon equals to 1. So you have 3 by 2 on x-axis, right, and then you have 3 on the y-axis. So just join these points. That will give you the graph of this line. Get your point? That will just give you the graph of this line. See, whenever you have a equation which is linear in one variable and quadratic in another variable, then that will be a parabola. You will read all these topics in your topic of coordinate geometry in mathematics. So if but we need all these things over here, so I am just giving you a brief details about these things, how we draw it. So if you have equation which is linear in one variable and quadratic in another variable, then it is a parabola. See, one thing I forgot in this line, if you have something like this, then this is a line passing through origin. This is a line passing through origin, right? If you don't have any constant, then that is a line passing through origin. You have extra equation x and y, and you don't have any constant, that is equation of a line passing through origin. Now, I was telling you, this was one point. The second point was, if you have equation which is linear in one variable and quadratic in another variable, then you call it a parabola. This is a parabola, right? So if your equation is say linear in y, linear in x, if your equation is linear x and quadratic in y, if your equation is linear in x and quadratic in y, then you try to reduce that equation into this form. You try to reduce that equation in this form, and once you do that, then your parabola can be drawn. First of all, whenever your equation is linear in x and quadratic in y, then you try to reduce that equation in this format, right? In this format, and then once you reduce the equation to this format, then you can draw this parabola. See, alpha and beta, just point here, alpha and beta, and your parabola would be this if a is greater than 0. If a is greater than 0, this is going to be the parabola, and if a is less than 0, then this is going to be the parabola. Get your point? For example, if suppose you have the equation this y square equals to 4x minus x square. So this is the equation. Get your point? You have equation which is quadratic in y. Oh, this is quadratic in both, in fact. Instead of this, let's put it like say y square equals to x, or say let me write x minus 4. Right, write it like this. So this is the equation of a parabola, and what is alpha and beta? Alpha is 4 and beta is 4 and beta is 0. So you just point here 4 0, and this is going to be the equation curve. If suppose I take this as, say, suppose this is y square minus 2y equals to x, suppose, then in that case I can put it in this equation which is quadratic in y and linear in x. So I can write it as, I'll try to put this equation in this format, or let's put here minus x, right? So I'll try to put this equation in this format. So for that I have to complete the square, 2y plus 1, I write like this, and this is what, y minus 1 whole square y minus 1 whole square minus of x minus 1. So your alpha and beta is 1 comma 1, and this is called vertex. So is 1 comma 1, and what is a is minus 1. So it will be this graph, right? So this is the equation of, this is the graph of this equation, right? So whenever your equation is linear in x and quadratic in y, you try to reduce into this form, you get the vertex and see what is a, whether it is positive or negative, and then you can draw that parabola. You can draw that parabola using this. If your equation is linear in y and quadratic in x, then you try to reduce this equation in this format. Try to reduce the equation into this format, and then you can draw the graph of this parabola. This is a parabola. If the equation is linear in one variable and quadratic in another variable, then that is a parabola. So you can draw that parabola. You just have to see what is alpha and beta, that will be your vertex. This alpha and beta maybe here also, here also, here also, but I'm just drawing first quadrant. And if b is greater than 0, your parabola would be like this, and if b is less than 0, your parabola is going to be this. So remember about all these things. Remember about all these things. One more thing. See, if you have an equation, say f, and this is x, and this is your curve, then suppose this is a, then area under the curve, the definite integral from a to b, represents area under the curve from x equal to a to x equal to b. So we can make use of it. Suppose this is velocity versus time graph, and the graph is like this. Say t equal to 1 second to say, or say t equal to t1, and this is t equal to t2. Then area under this velocity versus time graph will give you what? Integral of v dt t1 to t2. And what this is going to be equal to? See, your v was dr by dt. If it is one dimension, if it is motion one dimension, v was dx by dt, right? So this dx is v dt. So this is what? This is displacement. So v dt integral t1 to t2 gives you displacement of the particle from t1 to t2. This is giving you displacement of the body from t1 to t2. Similarly, if it is acceleration versus time graph, and this is t1 and this is t2, then this area will represent the change in velocity from t1 to t2. Change in velocity from t1 to t2. So that is giving you delta v is a dt t1 to t2. And one more thing, see the slope of the curve. So whenever you have any curve like this, then if you want if you draw the slope on the curve at this point, right, then this tangent slope, if you draw the tangent, not slope, sorry, tangent, if you draw the tangent at x naught, then if you draw the tangent on the curve at x equal to x naught, then slope of this tangent, slope is given by tan theta, tangent of the angle which the tangent makes with the x-axis. So slope of this tangent gives you the derivative of that function with respect to x at x naught. This is giving you slope of the tangent drawn at x equal to x naught. X equal to x naught. This point is what? X naught fx naught. So if I draw tangent to the curve at this point, then that is giving me the value of its derivative at x equal to x naught, and we'll make use of it. If I draw, say at t equal to t naught, if I draw the tangent, then slope of this tangent will give me the velocity of the body at this point. Slope of the tangent, here it will not give you velocity, here it will give you acceleration, because slope of the tangent will give you, here y is v, dv by dt, so that will give you acceleration. If it is distance by time graph, then if you take a tangent, the slope of this tangent will give you the velocity. Slope of tangent in a distance time graph will give you velocity. In a velocity time graph, if you take a tangent and then slope of the tangent at that point will give you acceleration of body at that point. Acceleration of body at that point. So we will make use of all these things. Right? Should I repeat? The area under the curve, this definite integral gives you area under the curve, and if you draw any tangent, then slope of that tangent gives you derivative of the function at that point. See, f dx integral will give you area under the curve, and if you draw any tangent at any point, then at that point it gives you the slope of tangent, at that point it will give you the value of df by dx. So keeping all these things in mind, we can discuss about the graph of various kind of motion which a body can undergo, right? So I'll discuss them one by one. Let's consider a body undergoing uniform motion. Uniform motion means velocity remains constant. Velocity remains constant. So of course acceleration will be 0 and x will be, or v is constant. Say v is v naught. So v is what? Dx by dt. So x can be written as v naught dt plus c, as v naught t plus some constant. So if at t equal to 0, x equal to x naught, so c will be x naught. So here x t is going to be x naught plus v naught t. So if I draw the displacement versus time graph, then how will you draw this graph? This will simply, this is equation of line between x and t. This is equation of line between x and t. So you try to reduce in this form. So if you reduce it to this form, this will be x by x naught minus t by x naught by v naught equals to 1. Can I write it like this? Should I write it like this? So on time axis you have here x naught by v naught on time axis. You have the point x naught by v naught 0. This is time axis, and here you have x naught, 0 x naught. So this is going to be the line, the equation of line. Oh, sorry. In fact, I committed a mistake. See here, this can be written as, please remember. So this is not the graph. This is mistake. Yeah. This is your time axis, x. So your say minus x naught by v naught, and here you have x naught. So your equation would be like this. But see, mathematics does not care whether time can be negative or not. But in physics we know that time can never be negative, right? So this part of the graph should not be drawn. In order to draw the graph, you can just draw it, but then you have to delete this part, right? So graph will be only from here to here because your time cannot be negative. So this part of the graph will not be physically possible. So better you can delete this part of the graph. But in drawing, this will help you. In drawing, you can just mark this point and draw the graph exactly. So, but thereafter you must delete this part, right? So a graph is going to be this. The graph is going to be this. And if initially x is 0, then the graph would go like this. When x naught is 0, the graph would go like this. This will be x versus time graph. Get your point? And velocity versus time. Velocity remains constant at v naught. This will be the graph. And acceleration versus time. Acceleration is 0. This will be the graph. Acceleration is 0. So acceleration will be lying on the time axis. A is 0. V is v naught. Right. So this is a uniform motion. This is about uniform motion. Now let's take case of uniformly accelerated motion. Uniformly. So in uniformly accelerated motion, what do you have? A is constant. So you have V equals to U plus AT, and distance is going to be, let's say distance is S, or let's put it as X, UT plus half AT square. So if you draw the graph of this, see velocity versus time graph, then again similar to what we have done in the previous graph, you can just write this as what? V upon U plus T upon minus U by A equals to 1. Can I write it like this? So minus U by A is this and U is this. So you have to draw the graph like this, but then your time cannot be negative. Then you have to delete this part. That's going to be our velocity versus time graph. That's going to be a velocity versus time graph. And if initial velocity is 0, your graph would be like this, right? The graph would be like this. What about this? See, this equation is linear in x and quadratic in t. This equation is linear in x and quadratic in t. So in that case it will be a parabola. It will be a parabola. So what's the way out? You just just put it like this. You try to, I told you that if your equation is linear in y and quadratic in x, then it is this kind of equation. This is the equation which is linear in y and quadratic in x. So you are here, see here also you are drawing x on the y axis and time is on the x axis. Time is on the x axis, and on y axis you are drawing displacement, right? So it is linear in y and quadratic in x. So graph would be either like this or it in the form of parabola. That will be very helpful. So your the x is the x equals to ut plus half a t square. So this can be put as a by 2 t square plus 2u by a t, and this is going to be u square by a square, that will complete the square. This will be x and plus u square by 2a. So this would be x plus u square by 2a equals to a by 2 t plus whole square. Getting a point? So this is of the form y minus beta whole square equals to x a minus alpha, x minus alpha, ax minus alpha. And this parabola, first of all you have to see the vertex. Where is the vertex? So xt, so if u is positive, a is also positive, the vertex would be somewhere over here, and the parabola would be, the parabola, if a is positive, the parabola would be like this, right? So but this part will not be there because t is not negative, t is never negative, so this part of the graph will not exist. This won't be physically acceptable, so you just have to delete this part, and this is going to be the parabola. This is going to be the parabola. It will be like this graph. I can draw it more in much better way. It will be like this. But remember, this won't be the vertex of parabola. It will be like this kind of graph. This would be the graph. This would be the graph. Clear point? So you just remember the equation of parabola and the equation of a line. If you have any equation where there is no constant involved, then that equation has to pass through origin. That is also very important. If in an equation you don't have any constant, then that equation has to pass through origin. Like over here, see, you don't have any constant, you don't have any isolated constant like 2 or 5 or say x naught, you don't have something like this. So that has to pass through origin, because when t is 0, x is 0 in that case. Alright, so this is how we can do velocity versus time and displacement versus time. If x is not 0 at t equal to 0, if suppose this is in place of this, if suppose it is x naught, then whole graph will get shifted by x naught. So instead of starting from 0, it will start from here, x naught, right? If it is x naught, then you have to just add, you can just shift the graph by x naught in upward direction. That will give you the graph.